Question number 23. Find all the point of discontinuity of f where f of x is equal to sin x by x if x less than 0, the x plus 1 if x greater than 0. We have to check the point of discontinuity at x equal to 0. So we have to find the left hand limit of x and right hand limit of x and f of x. If these three are equal, then it will be continuous. If these three are not equal, then it is not a continuous. So the given function is question number 23. That is f of x is equal to sin x divided by x if x less than 0, x plus 1 if x greater than equal to 0. We are going to check it at x equal to 0, at x equal to 0. So f of x, the function will be, this is less than 0, this is less than greater than equal to 0, so greater is here, greater than 0, so it will be x plus 1. So now f of 0, so instead of x it will replace by 0, it will give 1. So now left hand limit and right hand limit, limit x tends to 0 minus f of x is equal to limit x tends to 0 minus f of x, that is left hand side of 0, so it will be less than 0. So this will be the function sin x divided by x. So limit x, now it will be x tends to left hand side of 0 minus h, it will be sin x by x. Now x will be replaced by 0 minus h, limit h tends to 0 sin 0 minus h divided by 0 minus h, limit h tends to 0 minus 8, it will be minus h, and sine is a even odd function, therefore minus will come outside, it will give minus sine h divided by this minus h, 0 minus h, minus and minus cancel, so it will be limit h tends to 0 sine h divided by h. So this total is equal to 1. So this come to the one formula of class 11, that is limit x tends to 0 sine x divided by x is equal to 1. So instead of x, now it's h, so everywhere h, so this is equal to 1. So this is left hand limit. Now for the right hand limit, so right hand limit, that is x tends to 0 plus f of x, limit x tends to 0 plus the function is greater than 0, right hand side of 0, so it will be x plus 1. So x plus 1, so x plus 1, we can put it direct 0 instead of taking the h also. If you want, you can take the h. So limit, without taking, we can put it directly 0. Limit x tends to, okay, let's take it, limit x tends to 0 plus h, x plus 1. So limit h tends to 0, 0 plus h plus 1. So limit h tends to 0, h plus 1 equal to 0 plus 1, so it will give 1. So all three are equal. F of 0 is 1, left hand limit is 1, right hand limit is 1. So we got limit x tends to 0 minus f of x is equal to limit x tends to 0 plus f of x is equal to f of 1. It is a continuous function, therefore it is continuous. it is a continuous function at x equal to 0. Question number 24. Determined if f defined by f of x is equal to x square sine 1 by x if x does not equal to 0, 0 if x equal to 0. Is it a continuous function? We have to check it, is it continuous or not at x equal to 0. This is the function. We need the right hand limit and we need the left hand limit and f of 0. Question number 24. The given function is f of x is equal to x square sine 1 by x if x does not equal to 0, 0 if x less than 0. We are going to check at x equal to 0. So f of 0, so this is when f of x will be, this is equal to 0, so it will be 0 and f of 0 will be 0. Left hand limit x tends to 0 minus f of x, limit x tends to 0 minus less than 0. So this is whenever not equal to 0, this will be the function x square sine 1 by x, sine 1 by x. So it will be limit x tends to, now it will be x tends to 0 minus h x square sine 1 by x. Now replace it, limit h tends to 0, here it will be 0 minus h sine 1 by 0 minus h. So it will be limit h tends to 0, it will give h square sine 1 divided by minus h. So this will give 0, so this total will give 0 into, so here this will be lie between minus 1 to 1, minus 1 to 1, because sine it lies between minus 1 to 1, so it will give, multiply with 0, it gives a 0. So now for the right hand limit, right hand limit x tends to, limit x tends to 0 plus f of x is equal to limit x tends to 0 plus f of x, that is x square sine 1 by x, limit x tends to, now it will be x and 0 plus h f of x, so this will be x square sine 1 by x, the limit h tends to 0, it will be 0 plus h square sine 1 by 0 plus h. So limit h tends to 0, it will be 0 square sine 1 by h. So it will give 0 and this will be lie between minus 1 to 1, sine will lie between, sine 1 by h will lie between minus 1 to 1. So multiply with 0, it will give 0. So therefore here it is also 0, all the three are equal. F of 0, 0, left hand limit 0, right hand limit 0, so all these three are equal, so it is a continuous. So limit x tends to 0 minus f of x equal to limit x tends to 0 plus f of x is equal to f of 0. Therefore it is continuous, it is continuous. 25. Examine the continuity of f when f is defined by f of x equal to sin x minus cos x if x does not equal to 0, minus 1 if x equal to 0. We have to check the is it continuous at x equal to 0. Why it's x equal to 0? We have the value x not equal to 0 and x equal to 0. Therefore, we have to check the continuity at x equal to 0. So first let's write the given function. The given function is f of x equal to, this is question number 25. Question number 25, f of x is given, f of x is equal to sin x minus cos x minus 1 if x does not equal to 0, minus 1 if x equal to 0. We are going to check at x equal to 0. So at x equal to f of function is, this is the function, fx will be this one. So f of x is equal to minus 1 and plus let f of 0 it's a constant, we could put a 0, so it will remain the minus 1. Now left hand limit, there is left hand limit x tends to, since you are going to check the 0, so 0 minus f of x. So limit, now we are going for the left hand side, so x tends to 0 minus h, f of x is sin x minus cos x. Now instead of x, place the 0 value, limit, that is h tends to 0, sin 0 minus h minus cos 0 minus h. So limit h tends to 0, it will give sin, here put the value 0, here also h will be 0, so it will be 0, so it will be sin 0 minus cos 0. Sin 0 value is 0, cos 0 is, this minus will be minus, cos 0 is 1, so it gives the minus 1. So this is the left hand limit. Right hand limit, right hand limit, limit x tends to 0 plus f of x. So limit x tends to 0 plus h, f of x, it will be sin x minus cos x, because whenever x does not equal to 0, we have to take this function. When x is equal to 0, this is the function. So this is greater than, either it can be greater than or less than, the function would remain the same, because here is given x does not equal to 0. So cos x, limit h tends to 0, sin 0 plus h minus cos 0 plus h. Now 0 plus 0 also give the 0, so now instead of h it will give 0, so it will give sin, that is 0 plus 0 minus cos 0 plus 0, sin 0 minus cos 0, sin 0 is 0, cos 0 is 1, so it gives minus 1. So here also f of 0 is minus 1, left hand limit minus 1, right hand limit minus 1, so it is a continuous. So limit x tends to 0 minus f of x is equal to limit x tends to 0 plus f of x equal to f of 0. So therefore it is continuous. Question number 26. So it will be, find the value of k so that the function f is continuous at the indicated point in exercise 26 to 29. So already it's mentioned, they already give the point of continuous, at which point this function is continuous, and we have to find the value of k. In the previous question we have to check it is a continuous or not. So here it's a continuous, so f of x is equal, right hand limit of f of x equal to left hand limit of f of x equal to f of x. Already it's a given, so we have to find the value of k. One constant k is in every question k is there, so we have to find the value of k. So in the question number 26, f of x is equal to k cos x divided by pi minus 2x if x does not equal to pi by 2, 3 if x equal to pi by 2, at x equal to pi by 2. So this function is continuous at x equal to pi by 2, so we have to find the value of k. The function, given function, question number 26, f of x is equal to k cos x divided by pi minus 2x if x does not equal to pi by 2, and 3 if x equal to pi by 2. It's continuous at x equal to pi by 2. So it will be, it's continuous at x equal to pi by 2. Therefore, limit x tends to pi by 2 minus f of x is equal to limit x tends to pi by 2 plus f of x is equal to f of pi by 2. So we need a value of, let's find the left hand limit. F of pi by 2, so f of pi by 2 is 3. Okay, at x equal to pi by 2, f of x is equal to 3, f of x is equal to 3, so f of pi by 2, this is a constant, so it will remain the same. Now left hand limit x tends to, if we find one left hand limit is enough, either any of this we can find it out, because we need a value of k only, so no need to find a both the left hand, both the limit, only one is enough. X tends to pi by 2 minus f of x equal to, now because f of limit x tends to pi by 2 minus h, the function is k, this one not equal to is 3, not equal to, this will be k cos x divided by pi minus 2x. Now replace it, limit h tends to 0, k cos, that is instead of x it will be pi by 2 minus h divided by pi minus 2 pi by 2 minus h. Instead of h we have to put 0, so k cos pi by 2 minus 0 divided by pi minus 2 pi by 2 minus 0. So it will give k cos pi, this will give pi by 2 minus, this will give pi minus, it will be 2 pi by 2, this and this will cancel, this is equal to k cos pi by 2 divided by, wait, no, we cannot put this here, it will give 0, it will give undefined, so pi by 2, so it was cos pi by 2 minus h, it goes to in which quadrant, we have to go by the quadrant. So this is the 0 pi by 2, this is the pi. Now pi by 2 minus h, pi by 2, this is the pi by 2 minus h. So if you decrease pi by 2 minus h, pi by 2 minus h, so it will come here in the first quadrant. First quadrant all are, or first quadrant it is everything is all are positive. First, whenever it's come to this quadrant, means this axis pi by 2, so the sign will change to the cos. So limit h tends to 0, it will be k, so it will be sin h divided by, so it will be pi minus 2 multiply it, pi by 2 minus 2 h. So and this will eliminate, and limit h tends to 0 k sine h divided by, now pi minus 2h, this and this will eliminate. So here limit h tends to 0, we have k sine h divided by minus 2 h. Take the minus 2 in the front, k by minus 2 in the front, because they are constant. So it will be k divided by, wait, this minus and this is minus, and minus became plus. There is no minus, this is a plus. So it will be k by 2 limit h tends to 0 sine h divided by h. This total is 1, so k by 2 is equal to k by 2 into 1. So it will be k by 2. This is the k by 2, and we know that is limit, we are going to take the left hand limit x tends to pi by 2 minus f of x is equal to f of pi by 2, because it's already mentioned it is a continuous. So k by 2 is equal to, we got 3, already f of pi by 2 is 3. So we need a value of k is equal to 3 into 2, that is k is equal to 6. So this is the required value of k. 27, here also you have to find the value of k. F of x is given, f of x is equal to kx square comma if x less than equal to 2, 3 if x greater than equal to 2, at x equal to 2. Means this function is continuous at x equal to 2. We have to find the value of k. Question number 27. Question number 27. So f of x is given, that is k x square if x less than equal to 2, 3 if x greater than 2. So if less than 2, if greater than 2, greater than 2. Here we need the which limit we need? Okay, it is continuous, it is continuous at x equal to 2. So we need the f of x, no, f of x we need it, and we need a greater than limit x tends to 2 minus f of x is equal to limit x tends to 2 plus f of x is equal to f of 2. So f of 2, we are going to, from the f of 2 we are going to get k. See, when x equal to greater, if here we have the two left hand limit and two limit, one is left hand limit, one is right hand limit. So no need to find two of the limit to waste, because if we find these two result, that is right hand limit and left hand limit, we need only one, so it will be the waste of time. So find only the one limit. See the function, according to the function we have to choose wisely that which limit of the which limit you are to find out, so that you will get the answer is quickly. So here we have the function, so left hand limit, so this is the right hand limit. When it's a right hand limit, the function will be this one, 3. So here is the constant, we got 1, and when it's a left hand limit we will get this one, and when it is the f of 2 also we are going to get this one. So take the f of 2 and the right hand limit, take this 2. So it is it. So f of 2 will be f of at x equal to 2, f of x, that is, this is the function, so that is k x square. So it at f of 2, so it will be k 2 square, so that is 4k. Here we got 1. Now find the right hand limit. So this is the right hand limit function. So right hand limit, limit x tends to 2 plus f of x. So limit x tends to 2 plus f of x, limit is how much? This is the 3, that is equal to 3. So therefore these two are equal because it is a continuous.